Before a single stone could be placed, engineers faced an impossible question. Could an international airport really be built in the middle of the sea? Every meter of the seabed had to be measured with extraordinary precision. Engineers first needed to understand the ocean before they could reshape it. Within these invisible boundaries, engineers envisioned an airport that would eventually connect millions of travelers with the world.
Only after months of preparation could the first heavy equipment move into position. The construction site was finally coming to life.
With the placement of the first stones, an ambitious engineering vision began its transformation into reality. Each concrete caisson weighed thousands of tons. Positioning even one required extraordinary precision. Piece by piece, the protective seawall expanded across the bay, creating the first permanent boundary between the ocean and the future airport. Millions of tons of carefully selected rock were needed to absorb wave energy and protect the island against decades of powerful storms. As the final gaps narrowed, the engineers achieved something remarkable: an artificial shoreline where only open water had existed before. With the protective barrier complete, the ocean itself became the construction site. The next challenge would be even with the seawall complete, the next phase began. Millions of cubic meters of sand and rock would slowly transform open water into solid ground.
Every load of material had to be carefully placed and compacted. The island would only be as strong as the foundation beneath it.
Construction continued day or night. Coordinating dozens of vessels and thousands of workers required military-level precision. For the first time, the outline of the future airport became visible. What was once open sea was gradually turning into land. Creating the island was only the beginning. The newly reclaimed ground still had to be stabilized before it could support runways and terminals. Creating land was only half the challenge. Beneath the surface lay soft marine clay that could continue settling. Instead of avoiding settlement, engineers deliberately increased it. Massive temporary loads squeezed water from the clay. Every few millimeters mattered. Continuous monitoring allowed engineers to decide when each section of the island was finally ready to support permanent construction. After months of compression, large portions of the reclaimed island were finally strong enough to carry the immense weight of an international airport. The hardest part wasn't building on the sea. It was creating ground stable enough to support millions of passengers for decades to come. Long before the first aircraft could land, engineers had to build an invisible network beneath the surface. Every pipe, cable, and drainage channel. Rainwater could never be allowed to weaken the reclaimed ground. An enormous drainage system had to be completed first, protecting every future runway and taxiway above.
A runway is far more than asphalt. Beneath every landing aircraft lies a carefully engineered system of compacted
accuracy was measured in millimeters. Even the slightest variation could affect drainage, pavement performance, and the long-term reliability of the airport. The island was finally ready. After years of surveying, reclamation, and stabilization, construction could now begin. The first structural layer of the runway was not asphalt, but carefully graded crushed stone engineered to distribute enormous. Every pass of the compactor increased the strength of the foundation. Nothing could be left to chance beneath one of the world's busiest future runways. For the first time, the airport began to appear above the reclaimed ground. The runway surface was taking shape, meter by meter. Every layer was inspected before construction could continue. Precision today would determine the runway's reliability for decades. Years after the first survey boat crossed these waters, a runway now stretched across land that had never existed before. The airport was...
As the runway expanded, an equally complex network of taxiways began to take shape. Every curve and intersection, the aircraft parking apron would become one of the busiest areas of the airport. Its pavement had to withstand enormous loads every single day.
Much of the airport's most important infrastructure would remain hidden forever beneath the pavement, silently supporting every future flight. Even the lighting system demanded extraordinary precision. Every fixture had to guide aircraft accurately through darkness, rain, and low visibility. With the runways, taxiways, and infrastructure in place, attention turned to the heart of the airport, the passengers. While the runways stretched across the reclaimed island, another challenge was just beginning. The passenger terminal would require each steel column became another permanent piece of the terminal's enormous skeleton, carefully aligned to engineering tolerances measured in millimeters. The terminal slowly emerged as hundreds of steel members were assembled into a structure strong enough to span vast open spaces without interior columns. The terminal's sweeping roof became one of the defining architectural features of the entire airport, combining elegant design with remarkable engineering.
After years of work, the airport finally had a recognizable skyline, rising above the reclaimed island.
With the structural frame complete, the terminal finally began to take on its recognizable appearance.
Hidden behind the glass facade, thousands of systems had to work together seamlessly before the terminal could welcome its first travelers. These movable boarding bridges would eventually connect millions of passengers directly to aircraft. But first, every mechanical movement had to be perfectly aligned.
As construction entered its final months, attention shifted from massive structures to thousands of small details that would ensure safe daily airport operations.
With the runways, taxiways, and infrastructure in place, attention turned to the heart of the airport, the passenger terminal that would soon rise above the reclaimed island. Once construction was complete, another critical phase began. Every electrical system had to operate flawlessly before a single passenger could. Pilots depend on these lights in rain, fog, and darkness. Every fixture had to be tested, calibrated, and verified before flight operations could begin. Behind the scenes, thousands of independent systems had to perform together as one. Reliability was just as important as construction itself. Before commercial service could begin, every meter of pavement and every navigation system had to prove itself under real operating conditions. Years of engineering, millions of tons of material, and countless hours of precision had transformed open water into a fully operational international airport. Months of testing had led to this moment. Every runway light, every navigation system, and every safety procedure had been verified before the airport could open.
The first successful landing marked the transition from construction to operation, proving that an airport built on the sea could perform like any built on solid ground. Behind every departure and arrival lies an invisible network of engineers, controllers, and ground crews working together around the clock.
Designed to withstand harsh coastal conditions, the airport continues to rely on constant monitoring and maintenance to protect the artificial island beneath it.
What began as open water became one of the world's most remarkable engineering achievements, redefining what was possible in offshore construction.
The arrival of the first commercial flight marked the beginning of a new chapter. What had once been open sea was now a gateway connecting Kansai with the world.
Building the airport was only the beginning. Engineers continue to monitor settlement across the artificial island. Every successful departure depends on thousands of coordinated actions happening behind the scenes, from maintenance crews to air traffic controllers and ground operations.
Surrounded by the sea, the airport requires constant inspection and maintenance. Its seawalls, drainage systems, and monitoring equipment protect the island against the forces of nature.
More than an airport, Kansai became a symbol of engineering ambition, demonstrating how careful planning.
As air travel continued to grow, the airport had to evolve. Expansion became the next engineering challenge.
Unlike the original construction, expansion had to take place while millions of passengers continued using the airport every year. Even after opening, engineers continued monitoring settlement across the artificial island, adjusting maintenance plans to preserve long-term safety and performance. The seawall remains the airport's first line of defense. Continuous inspection helps protect the reclaimed island from waves.
An airport is far more than runways and terminals. It is a living system where thousands of people and technologies work together every hour of every day.
Kansai International Airport was designed as more than an airport. It became a transportation hub linking air, rail, and highway networks across western Japan.
Every day, thousands of passengers and tows of cargo pass through the airport, strengthening trade, tourism, and economic connections throughout the Kansai region. The project demonstrated that even the most ambitious engineering challenges can be overcome through careful planning, continuous innovation, and decades of collaboration. The work never truly ends. Continuous monitoring, maintenance, and upgrades ensure that the airport remains safe.
From open water to one of the world's most remarkable offshore airports, Kansai stands as a lasting reminder that engineering can reach.
Every movement across the airport is coordinated from a single location. Air traffic controllers manage dozens of aircraft simultaneously. Beyond concrete and steel, a digital nervous system continuously monitors the airport, allowing engineers to detect problems long before they become visible. Because the airport rests on reclaimed land, engineers continue monitoring settlement every day. Small movements are expected, but they must.
Living beside the sea means preparing for nature's most powerful forces. The seawalls, drainage network, and emergency systems work
while passengers sleep. Maintenance teams keep the airport operating safely. Around-the-clock inspections ensure every new day begins with complete confidence. The airport required millions of tons of stone, sand, steel, and concrete, each delivered, placed, and assembled with extraordinary precision. What emerged from the sea was far more than an airport. It became a self-contained city, with transportation.
Behind every structure stood thousands of engineers, construction workers, pilots, technicians, and planners whose combined expertise turned an ambitious vision into reality.
The lessons learned here continue to influence engineers working on complex coastal infrastructure around the world. What once existed only on engineering drawings now stands as a fully operational international gateway, built where no natural land had ever existed. It all began with an empty stretch of sea. Years later, the same horizon tells a completely different story. The first vessels carried engineers and survey equipment. Today, aircraft carrying millions of passengers follow the same route into Kansai.
Every phase depended on the success of the one before it. No shortcut could replace careful engineering and disciplined execution.
The project was remarkable not only because of its size, but because every critical detail demanded extraordinary precision.
Kansai International Airport remains one of the world's most recognized examples of large-scale offshore engineering.
Completion did not mark the end of the project. Continuous maintenance and monitoring remain essential to its long-term performance. Behind every successful operation are thousands of professionals whose expertise keeps the airport running safely every day. The knowledge gained from this project continues to influence engineers working on complex coastal infrastructure around the world. Designed for decades of service, the airport continues adapting to changing technology, growing demand, and the challenges of the marine environment.
What once existed only on engineering drawings now stands as a fully operational international gateway.
This is more than an airport. It is the result of vision, persistence, and engineering on an extraordinary scale. No single team could have completed a project of this magnitude alone. Success depended on years of collaboration across countless disciplines. Kansai demonstrates how engineering can overcome extraordinary constraints while respecting the realities of the environment. From above, the scale of the achievement becomes unmistakable. A complete international airport created from the sea. Every new day begins with the same purpose that inspired the project from the very beginning: connecting people through engineering. From the bridge to the runway, every structure tells part of an engineering story unlike any other. As daylight fades, the airport continues its mission, operating safely through every hour, every season, and every year. An idea that once seemed impossible now serves millions of travelers, standing as one of the defining engineering achievements of modern aviation. Thank you for joining us on this journey through one of the world's most remarkable infrastructure projects. Lieutenants, if you enjoyed exploring this incredible engineering achievement, subscribe for more documentaries about the world's most ambitious construction.